All right, welcome back to computer vision again. We're going back to recognition now. Remember before we were talking about supervised classification? Supervised classification is I give you a bunch of labeled examples, right? Typically referred to as training examples. And you're supposed to come up with a function that'll label some new examples. And we showed this one where we have a bunch of hand-drawn 4s and hand-drawn 9s. And the idea was, given some new input, is it a 4 or is it a 9? The idea was, since we know what the desired labels are from the training data, we're going to try to build a classifier that's going to minimize the expected misclassification or minimize our risk. All right? And we talked about that there were two strategies. One was called generative, where we probabilistically model each of the classes and then somehow pick them. We'll talk about that again just for a second. And then there was discriminative. And discriminative says, I don't care so much about modeling the classes. What I care about is modeling some sort of boundary between the classes, and that makes it easier to make some decisions. So we talked about the risk of a particular decision as being, if you're making a particular decision, what's the probability that that decision is wrong, and what's the cost of making that wrong decision. So for example, let's suppose that I'm going to label something as a 4. Well, if I'm going to label it as a 4, what's the risk associated with it being a 4? Well, that risk would be, well, you know, what's the probability that it's actually a 9, okay? And what's the cost to me of calling a 9 a 4, all right? So that's the risk of labeling something a 4, right? Because it actually might have been a 9, and what's the cost? Likewise, suppose I'm going to label something a 9. What's the risk of labeling something a 9? Well, the risk of labeling something a 9 is the probability that it was actually a 4 times the cost of labeling something a 4 as a 9, all right? And where should my decision boundary be? Well, my decision boundary should be that the risk of either decision would be the same. Okay, and that was the idea of the generative model. And so that's what's being shown here is, so here are all my real 4s, so I'm pretty sure that they're 4, so I'm going to call them 4s. But as I'm getting over to the other side, it might be a 9. Here are all my 9s. And as I'm getting closer over here, it might be a 4. And this boundary in the middle, that's where the risk is the same.